Because they change them up on stuff. I know. It's so mean. All right, anyway. All right, now, we're going to factor today. And you guys, this skill is so important. I mean, I help kids in calculus do this in the resource room all the time. So factoring is super important. You'll see it more often this year. You'll see it in pre-calc and trig. You'll see it in calculus. This is a super important skill. We're going to first start with just a greatest common factor, and then we're going to focus more on the quadratic stuff that we've been working on because our unit is really on quadratics, but just the skill of being able to factor is important. So we're going to do just greatest common factor here at the beginning. Okay, so greatest common factor can be a number, can be a variable, can be a number and a variable, but it's basically the biggest term you can think of that would divide evenly into each term that you see in front of you, and we basically like undoing a distributive property is kind of how it works. So, like if I look at my first problem, I have 15x squared and 25x. What's the biggest number that would go into 15 and 25? 5. Okay, now, do we have a variable in common here? Okay, they both have at least an x. So that would be what we would call our greatest common factor, right? 5x. Now, to factor something means in this situation, if you have a greatest common factor, it's just like undoing a distributive property. And you don't have to write this out, but essentially what you're doing is you're going to divide that greatest common factor for this first question, that's 5x. I'm going to divide that and take that out in front of a set of parentheses. You just have to tell me after you figure out that greatest common factor and pull it out, what would be left. So what would be left if I took 15x squared and divided that by 5x? What do you think? 3x. Okay. And what would be left if I took 25x and divided that by 5x? Just a 5. Just a 5. The x divided by x would become 1. That's all you have to do. All right. Tell me the biggest number that goes into 28 and 8. 4. And then you got an m. I have at least an m in each of those terms. So 4m would be my greatest common factor. So I'm just going to take and divide each of these guys by 4m. Like I said, it's like undoing the distributive property. So that lovely greatest common factor goes out in front. Okay, what would be left over? 7m, right? You're going to take 1m out, 1m will be left. And what would be left over in the other term? Just a 2. And that would be what we call our factored form. Eventually, we're going to use this to solve equations, and we're not solving anything today. You will not see a single equal sign in any problem. We're just factoring today. So what we have written out there would be called standard form because it's all multiplied out. What we're writing as our answer is the factored form. Okay, what would you tell me the greatest common factor is between 6x and negative 3? 3. You could do 3 or negative 3. In this case, I would recommend 3. What you would want to look for, you would want the first term in your parentheses that you're going to have after you do this factoring. You want your first term to be positive. So I just want to take out a 3 here. So this would be 2x and then what? Minus 1. Okay, now I cannot tell you how many times people will mess this up. They'll take like the 3 divided by the 3 and they just won't write that term, right? They'll just write like 3 times 2x, which is not the original problem. If you get something divided by itself, it exists, it's there, it becomes 1, or in this case, negative 1. So don't just like drop off a term. If it has 2 terms, you should have something out in front and a parenthesis with 2 terms. Don't just drop something out. All right, what do 63x and 27 have in common? 9. All right, so I'm going to take a 9 out in front of both of these guys. So what would be left? 7x plus 3, perfect. All right, now I'm going to just make a little recommendation to you guys underneath here. These, or a couple of these, yeah, just E and G, they're not written in standard form. So I'm going to rewrite this real quick in standard form. So that just means the highest power of my variable. I'm going to write that first. Okay, now here's the other thing. Remember you guys, we just were talking about on letter C. And we said it could be 3 or negative 3, and I said you want the first thing in your parentheses to be positive. So I want that here, but I want it in standard form first. So what I'm going to do here, what do these 2 terms have in common? Y. Okay, now I want my first term to be positive. So if y is the only thing that they have in common, they also have 1 in common in terms of a number, I'm going to take out a negative y. That's what I'm going to take out in front of this. So I'm going to divide each of these guys by negative y. You always, always, always want the first thing in the parentheses to be positive. It makes any other factoring you might have to do easier to work with. So I would pull out a negative y. Now, left over, I would have positive 9y then. And then that would change this middle term, or the second term, sorry, just to be negative 7. But you want that first number that's inside the parentheses, you always want that to be positive. So if everything's divisible by 2, it's also divisible by negative 2. So you might just take out a negative number. All right, what's in common between 5x cubed and x? Okay, so if I take out an x, now this has a little bit higher power of a variable. So what would be left in the first term? 5x squared. So you have x to the third, you're going to take 1 out, so you'd still have 2 left. What would the other term be? 1. Good. Don't drop it off. All right, now let me rewrite this last one so it's in standard form. So I would put the negative 6x to the 5th first and then the minus 16x squared second. That's standard form. That just means your variables should go down in order from highest exponent to lowest. So that was not written properly. What number and or variable can I take out of these two terms? Negative 2, and then you have at least x squared in each of those terms. So I'm going to divide each of these by negative 2x squared, because I want that first term in my parentheses to be positive. So the negative 2x squared out in front. Now, the first one would become positive 3. What would my exponent be? X to the third. You're going to take 2 out when you take out that greatest common factor, so you have 3 left. Now, the other term, 16 and 2, whoops, this will change to a plus, so that'll just be 8. And then x squared divided by x squared, that would become 1, so you would not have a variable in that second term. Is anybody having a question? Okay. Now, the rest of today we're going to focus on factoring what we call perfect square, or not perfect square, quadratic trinomial. The word trinomial, does anybody know what that means? Just means 3 terms, like a tricycle has 3 wheels, a trinomial has 3 terms. So it just means 3, like if you look down at any of these expressions, like I've got x squared plus 10x plus 24, I have 3 different terms, quadratic, linear, and constant. Now, all the ones we're going to focus on today are going to have nothing in front of the x squared. You'll have an x squared, but it will just be a 1 for your a value. Okay, now I'm going to write this for today, because it works for what we're going to do in our next lesson. But you are going to find 2 numbers that when you multiply them together, they will give you the product of whatever a times c is, in my ax squared plus bx plus c. Now today it's just going to look like I'm doing the c value, but I'm setting you up for if we have an a value other than 1. You got to multiply the first coefficient, the last term, which is the constant. You're going to have 2 numbers that multiply to get you that product, and the same 2 numbers add to get you the b value. You need 2 numbers that fit both of these requirements. There's only 2 numbers that will fit both of these requirements. And I have these separated a little bit, so let me explain what it means. So this says factoring, a is 1, that's true for all these questions. This says c is greater than 0, so that just means my constant term is positive, and the b value is greater than 0, which also means the b value is positive. So basically, each one of these is just a plus plus in between the terms. If that's the case, these 2 numbers that I'm talking about are both going to have to be positive to make this happen. All right, now, if you've learned to factor in a different way, that's totally cool. If you want to do your way versus mine, that's fine. Just bear with me for this so I can show it to you, because I promise it works every time if you can find the 2 numbers. All right, factored form looks like what we would start out with before we would do a FOIL. So I'm trying to reverse the process of the FOIL. Now, if it starts with an x squared, both of your little sets of parentheses are going to start with an x squared, because x times x is x squared. Now, to fill in those parentheses, I need you to tell me, okay, I'm just going to write m for multiply. Okay, so you're going to take the first number, which is 1, times the last number, just a times c, 1 times 24. I need 2 numbers that if you multiply them together, it would give you 24. and I'm going to write A for add. The same two numbers, I would add these same two numbers together that multiply to give me 24, and they would add up to give me 10. Now, I'm sure some of you already know right away. I'm just going to tell you something real quick. If you have trouble coming up with this combination, I just start writing numbers that multiply to give me 24. So like any combination I can think of, like one and the number always, 2 and 12 here for 24, 3 and 8, 4 and 6. Those are all the possible multiples of 24. What combination is going to multiply to get 24 but add to give me 10? 6 and 4. All right, so it doesn't matter the order. One of these is a plus 4. One of these is a plus 6. That's the answer. This is the factored form. Okay, now just on this question, let me show this to you. I'm going to FOIL this back out, and I'm going to show you it gives me this original problem and kind of try to explain why this multiply add things works. All right, so x times x give you back the x squared, right? Now, the reason it's add to get 10, watch these middle terms. I do x times 6, so I get plus 6x. Then I do 4 times x, so I get 4x. And then if I combine those, that gives you the 10. That's why it's add to get that number in the middle. And then on the end, you do 4 times 6. That number on the end is 24. So that's why I'm trying to multiply to get that number on the end, add to get the number in the middle, because that's what you would do in the process of the FOIL. So you guys can see, like if I actually combine my like terms there, that gives me back the original problem. So you can check these if you want to, but as long as it multiplies to get you the number on the end and adds to get the number in the middle, you should be okay. So let me try another one here. All right, so I'm going to just set up my factors, right? It starts with x squared. So I know both of my factors, x and x. That'll multiply to get me x squared. To fill them in, you're going to multiply to get the number on the end. So it'd be like 1 times 6 here. And it's always add to get the number in the middle, which is 5. Can we think of two numbers that you multiply them, it would give you 6, but you add those same two numbers, it would give you 5? 2 and 3. So just one of them's a plus 2, one of them's a plus 3. That's your answer. That's the factored form. Again, if you FOIL it out, it just gives you the original problem. All right, I got one more like this. So again, it starts with x squared. So I know both of my factors have to start with x and x. All right, so on this one, I'm going to write m for multiply. Okay, it's the first times the last. So 1 times 8 would be 8. And I'm going to add to get the number in the middle, which is 9. This one I think is tricky. Can anybody raise your hand and tell me what two numbers multiply give you 8, add to get you 9? 8 and 1. So one of them is plus 1, one of them is plus 8. 1 times 8 is 8, 1 plus 8 is 9. There's only two numbers that'll fit both of those requirements we were trying to fit, and so it doesn't matter the order. Let me just write this on this question at least. When I keep saying it doesn't matter the order, I mean like you could write x plus 8 times x plus 1. Like that's the same thing. This one I could do like x plus 3, x plus 2. That one I wrote all over, but you can flip the order of the parentheses when I keep saying the order doesn't matter. Is anybody having a question? Okay, now this example I think can be really tricky. So at the bottom here, let me scoosh this up. All right, a value is 1 on all these questions today. This says the c value, so the constant term, the plain number, is greater than 0. So the plain number is positive, but the b value is negative. Okay, now the only way this is going to happen, you're going to multiply to get a positive number and add to get a negative number. In this case, and it goes minus plus if you're looking at the terms, minus plus, each one of these. Both of these factors are going to have to be negative to make this happen. So this can get kind of tricky to kind of figure out the right combination. So on this one here, I know every single one of these are going to start with x and x. X times x is going to give me the x squared. All right, now on this one, I got to multiply the first times the last. So this would just be 1 times 33. So I'm going to multiply to get positive 33. Add up to get the number in the middle, which is negative 14. Okay, only way to multiply to get a positive number, add to get a negative number, they both have to be negative. Two negatives multiply to give you a positive, but two negatives added together will give you a negative. Can anybody think the two numbers? Okay, he says negative 11, negative 3. Negative 11, negative 3, that's your answer. If you do negative 11 times negative 3, that's positive 33. Negative 11 plus negative 3, that's that negative 14. So you don't have to write that out, but just to show you, there's only two numbers that fit both the requirements. All right, let's see if you guys can do, here I just wrote all over that. All right, so this one, I'm going to multiply to get 12 and add to get negative 7. Both of my factors have to start with x to give me the x squared. Can you think of two numbers, you multiply them together, it would be 12, but you added them together, it would be negative 7. 3 and 4, they just both have to be negative. So one's a minus 3, one's a minus 4. And you can flip the order, put the x minus 4 first, the x minus 3 second. Okay, now I have one last one. This is actually a special case, but you might not notice that right away. I'm going to multiply here to get 81 and add to get negative 18. Can anybody think of two numbers, if you multiply them, it would be positive 81, but you add those same two numbers, it would be negative 18. Negative 9 for both. Negative 9 times negative 9 will give you the positive 81. Now, before you flip the paper, tell me another way I can write this answer. Yes, you guys know this. If these are identical, you can squish them together and you just write it as one factor but squared because they're exactly the same. So that would be x minus 9 squared. That last one's called a perfect square trinomial. We'll get into this later in the unit, that specific term, but all of those guys should be in factored form. All right, now, this guy is the most difficult. All right, now, this has only one requirement, and the A value you'll see is 1 in all these again. It doesn't matter what B is. You'll see a couple are plus, a couple are minus. This just says C is less than 0, which means the constant or the plain number at the end of that is going to be negative. Okay, if that's the case, you're going to have to multiply to get a negative number. The only way to get that to happen, and these are the trickiest, one of the numbers you're going to tell me is positive, and one of the numbers is going to be negative. And just remember, there's only two numbers that are going to fit both of the requirements, but this can be a little bit harder to kind of figure out. So, I've got x squared plus 3x minus 28. So I got to have you tell me two numbers that multiply to get you negative 28. Same two numbers add to get you positive 3. Negative 4, positive 7. Right? That's the only combination that'll fit both of those. If you take negative 4 times 7, that's negative 28. Negative 4 plus 7, though, that'll give you the 3. All right, I think this one's always tricky. All right, I got to multiply on this one in the middle to get negative 30 and add to get negative 1. And again, if you ever get tripped up, 30 has a lot of options, right? But if you get tripped up, I just start writing numbers that multiply to give me 30, like 1 and 30, 2 and 15, 3 and 10, 5 and 6. And then sometimes if I write those out, then the combination will kind of stick out to me a little bit more. So if you get stuck, just write out factors of that number and then see if you can figure it out. So what two numbers would multiply get me negative 30, add to get me negative 1? It's got to be the 6 and the 5, right? Which one has to be negative? The 6, because I want it to be negative 1. So it has to be x minus 6, x plus 5. Okay, now, again, let me say this before I do the next question. You can switch the order of these, but I do not mean you can switch like where the plus and minus. Like you could write this as x plus 7, x minus 4. You can switch the order of the little parentheses. You cannot switch the plus and the minus, though. Like on this one, the minus has to go with the 6 and the plus has to go with the 5. But you can write these where the parentheses switch order. All right, let's do one last one. So the last one, what do we have? My goodness, I'm running out of space. I'm going to multiply to get negative 50, and I want to add to get negative 5. Can we think of two numbers? I know both of the factors are going to start with x. Can you think of two numbers when you multiply them, it'd be negative 50, the same two numbers, you'd add them, and it would be negative 5? Negative 10, positive 5. Negative 10 times 5 is negative 50. Negative 10 plus 5 is negative 5. Is anybody having a question? All right, now, this last example, and then I'm going to do a special case with you guys with difference of squares. If you have a greatest common factor between all the terms in anything you're trying to factor, if you do not take that out first, what I just worked with you on will not work. So anytime you're doing a problem, just take 1 second just before you start, just spot check and make sure there's no greatest common factor like we had on that very first example. Any kind of a question in the directions that says completely factor is trying to imply to you that there should be a greatest common factor, and you need to take that out first before you try to apply the little trick I was showing you, multiply and add to get whatever. Now, if you guys look at these, all these are divisible by 3, right? So take that out in front first. So this be x squared minus 4x plus 3. And then what I'm going to do, we're just going to leave that 3 out in front. And we're going to try to factor what we had left over. That's what that completely means. It's trying to tell you there's probably a greatest common factor. In this case, all those terms are divisible by 3. And then we're going to do exactly what we did on the front and right above here, actually. So I'm going to keep the 3, that greatest common factor, out in front. And then I'm going to need to fill these in, 2 numbers that when I multiply them, I get 3. When I add them, I get negative 4. Very tricky. What do you think? Yes. Okay, good. One of them is negative 3. One of them is negative 1. So negative 3 times negative 1, that gives you positive 3. Negative 3 plus negative 1, that gives you negative 4. And again, you could put the x minus 1 first and the x minus 3 second. The 3 does need to be in front for this problem because we had that greatest common factor. All right, now I also had one like this on the front. Remember I told you if we have a greatest common factor, if we have parentheses, we want the first thing in the parentheses to be positive. So since this starts with a negative 2, all these guys are even. I'm going to take a negative 2 out in front first. The reason for that, I want this to be a positive beginning term. So that'll make that first term x squared. The second term will become plus 4x, and the last term will become negative 21. Then to fully factor this, because it says completely, so we're going to completely factor it, I'm just going to keep that negative 2 out in front. All right, and I know both of the factors are going to start with x. So for this one, I got to multiply to get negative 21, and I need those same 2 numbers to add to get 4. What do you think? Yes, ma'am. Okay, so 1's a plus 7, 1 is an x minus 3. If you do negative 3 times 7, right, that's negative 21. Negative 3 plus 7, that's 4. Is anybody having a question? Yes. Okay. I'm going to be like a Desmos professional by the end of the year. Probably not. Probably not. All right, now at the very bottom, I just have a list of perfect squares, and this just goes up to 15. We could continue this list farther, but perfect square just means if I take a square root, it's a nice number. And the reason I'm putting this on here for you guys is if you see these numbers, and you might have what we call a difference of squares, you'll notice these just have 2 terms, right? They don't have 3 terms, they just have 2. So, difference, what does the word difference mean to you for like a mathematical operation? Subtraction. Somebody last period said division and I almost fell. Okay, anyway, like literally, like I almost tripped on my shoe. I was like, what? Okay, difference means subtraction. So you'll notice between each of these terms here, you will see some lovely subtraction. Okay, now, the way this works, difference of squares has to be subtraction in between the 2 terms. This can be factored into, and it doesn't matter which one comes first or second, a plus b times a minus b. They're identical except for this symbol in the middle. One's a plus, one's a minus. Okay, now, the a, like basically it's just the square root. So if I do the square root of a squared, the square root and the squared cancel each other out. That would be where the a comes from. If you do the square root of b squared, the square root and squared, again, those cancel each other out. That would be the letter b. So to work this one out, like, what would you tell me the square root of x squared is? Just x. What would you tell me the square root of 36 is? Okay, so those are the two terms. So just one of them is an x plus 6. One of them is an x minus 6. That's called a difference of squares. This also would work if I asked you the same question I did on the previous problems. If I said to you, okay, tell me two numbers that multiply to get you negative 36, but I don't have a b value, right? So it would be multiply to get negative 36, add up to 0. That would also work. It would be 6 and negative 6, or you could just take the square root. Now, let me show you just super quick. If you were to actually FOIL this back out, the reason this works, you get x squared, you'd get a minus 6x, but then you turn around and get a plus 6x. So that wipes out those middle terms if you would combine them. And then it's very important, it has to be subtraction, because the term on the end, you'd have 6 times negative 6, which is negative 36. So that's why it has to be a minus. If there is a plus in between the two terms, there is not, it's actually imaginary to factor it, but we're not going to worry about that right now. So it has to be something minus something, and they both have to be something you could take the square root of. All right, so for example, square root of x squared, you told me was x. What's the square root of 25? Okay. All right, so just one of them, x plus 5, x minus 5. That's it. Square root of x squared, you don't have to write this, but I'm just writing it on my paper. Square root of 121. Everybody know that? 11. So one of these would be x plus 11, x minus 11. Now I get to the third problem, and I'm saying, Miss Grody, neither of those numbers are perfect squares. You are a moron. Why did you put this on the paper? Well, that's what I say to myself anyway. All right, now, if they're not on this lovely list, which they're not, what do you think I should maybe do? Divide by 6. They have a greatest common factor. And if you take a 6 out in front, you get x squared minus 9. And then you're like, oh, maybe Miss Grody's not an idiot, but she probably is. Okay, so we're just going to leave the 6 out in front. Now, we're going to have 6 here. Square root of x squared would be x, right? What's the square root of 9? 3. So one of these would be an x plus 3. One would be an x minus 3. The main difference there is you're going to have the 6 in front because we had a greatest common factor. We did not have that in the previous two questions. But if you do have a greatest common factor, take that out in front first. Okay, now this is something I frequently see on problems. It'll be more in a unit that we'll do a little bit later, but this is a really good practice to have. Okay, let me first write this in standard form. All right, so I have negative x squared plus 4 if I had written that in standard form. And again, you're like, wait a minute, that's not a difference of squares because I'm adding between these two terms if I write it properly. What I would tell you in this scenario, does anybody know what I'm going to factor out of this? Negative 1. You want that first thing to be positive. I'm just going to take a negative 1. If you do that, just put a little negative sign in front of this, this does become a difference of squares. It'd be x squared minus 4. I'm just factoring out a negative 1 to make that happen because I want that first thing in the parentheses to be positive. And then this is just, it's going to have a little negative symbol in front of it. Both of these guys are perfect squares. One's an x plus 2, one's an x minus 2. So you might run into something like that algebraically.
If I wrote it like 2 minus x parentheses 2 plus x, would that work?
If you wrote it, yes, that would work too. You would not have a negative in front of that in that case. I'm just practicing that with you, but yes, that's correct also. It's just another way to write it. I'm just recommending this to you because I know we're going to run into stuff like this later on to pull a negative out and make that first term positive. But that is actually correct as well. Now, these guys are both, I'm going to rewrite this, 3x squared plus 48. These guys are both divisible by 3, but I'm going to pull out a negative 3 to make that first term positive. And then that'll give you a difference of squares because you have x squared minus 16. So I just do negative 3, one's an x minus 4, one's an x plus 4. Doesn't matter which one comes first or second. Okay, now on the very last one, I haven't had any questions like this today, but my a value is not 1 here.